Welcome to our very first episode of Precision in Under 10 Minutes. Let's keep that mystery going. Which measuring device should I choose? So let me get this straight. So, what do we have today? Which component should I choose to optimize my design? This one looks good, but is it the best choice for my design? It's good that I will be supported in my decision today by suitable measurement instruments. On my bench to help me are an LCR meter and a VNA. Do you know when we use each measuring instrument and what exactly we measure with them? Hi, my name is Masha, and today I will show you when to use an LCR meter and when to use a VNA. The context in which the different types of measurements are placed is important. For this reason, I have an expert from Rohde & Schwarz as a guest today who can explain exactly when each measuring device is used. Hi, Tim.
Hi, Masha. Thanks for having me on the show today.
Thank you for coming on. Tim, I have some components and circuits on my bench today, and I'd like to measure their properties. Which measuring device should I choose in order to evaluate them?
Sure. Well, first of all, it's important to understand exactly which instrument measures what and how.
Let's start with the LCR meter.
Okay, so an LCR meter measures a physical property called impedance. This indicates the total resistance of a component to an AC current. It can be used to measure passive components, and we measure the inductance, capacitance, and resistance, as you mentioned earlier. The components that we can measure comprise of resistors, capacitors, inductors, but also transformers and diodes.
That clarifies the name.
Right. In fact, the name LCR is derived precisely from its function.
Right.
So with the LCR meter, we're measuring the basic electrical properties of components at low frequency.
Okay, and so by low frequencies, we mean up to 10 megahertz.
That's right. There are instruments which operate in the kilohertz range, but there are also instruments which operate right up into the megahertz range. And this is an important consideration when you're measuring parameters such as equivalent series resistance of your capacitor or your inductor.
Got it.
All right, then let's have a look at the VNA. A VNA is a more advanced measurement instrument. It measures the complex transmission and reflection characteristics of one-port and multi-port devices. It measures the so-called scattering parameters, which are also known as S parameters. It can be used to characterize the performance of amplifiers, antennas, filters, cables, and any other RF components.
What else do they measure?
With the VNA, you can characterize components wherever it's important to measure magnitude or phase, or where input-output comparisons are important.
So VNAs are good for a wide frequency range.
That's right. They start at the kilohertz, but they can go right up into the many hundreds of gigahertz on the high-end devices. They can be used to measure parameters over the full frequency sweep, and you can measure passive components such as couplers and antennas, or active components such as amplifiers and transmitters.
So let me get this straight. The choice between an LCR meter and a VNA depends on frequency range of measurements and whether or not I want to measure transmission and reflection characteristics. In other words, LCR meter delivers LC or R values, and if you need transmission and reflection characteristics, you need to use a VNA with S parameter function.
That sums it up very well.
For simple low-frequency single components test, an LCR meter is sufficient. For more complex network analysis, a VNA is required across a variety of frequencies.
And that's the key difference. With a VNA, you can measure frequency-dependent network behavior, even if the network consists of only one component. A VNA can offer a great graphical data representation called a Smith chart. Another key difference between the two is the types of components they can measure. A VNA can test both passive and active components, while LCR meters are generally limited to passive components only.
What are the main use cases for both products?
You'll find LCR meters on the lab bench to measure discrete passive components such as capacitors, inductors, or resistors. When it comes to a VNA, you'll also find these on the lab bench to characterize RF components such as filters and antennas, helping you optimize the design and ensure compliance. Both instruments can be automated, making them ideal for a production environment.
Thank you, Tim. I would be curious to know which of these two measuring devices are more relevant to you. Please let us know by leaving a comment down below, and don't forget to subscribe to our channel to never miss an episode of Precision in Under 10 Minutes. See you next time.